So homework 2, problem 1.2, we have exercise 4 that says the limit as x approaches infinity of e to the x plus sine of e to the x over e to the x plus 1. And the first step is going to be identifying the dominant term within the function, which is e to the x, that exponentially grows the fastest. And we're going to divide every term within the function by e to the x. And now we're going to proceed to simplify the terms that can be simplified, such as e to the x over e to the x simplifies as 1. And now we're going to apply the product and sum rule all together to evaluate each term within the function as an individual limit. Now we're going to evaluate each individual limit. First up, we have the limit as x approaches infinity of 1, which as we know is 1. And then to evaluate the limit as x approaches infinity of sine e to the x over e to the x, we're going to use the squeeze theorem. First up, we're going to just set up the sine of e to the x between its boundaries, which is -1 and 1. And in order to get the boundaries that we need for sine e to the x over e to the x, we're going to divide everything by e to the x. So now we're going to rename these functions as a theorem, as a squeeze theorem states, as f, g, and h. And then knowing that the limits of -1 over ex and 1 over ex is 0, consequently we know that the limit of g will be bounded between the limit of f and h. So the limit of g will be 0. With the help of the squeeze theorem, we found the limit as x approaches infinity of sine e to the x over e to the x, which is 0. Then in the denominator, we have the limit as x approaches infinity of 1, which we know it's 1, and then the limit plus the limit as x approaches infinity of 1 over e to the x, which we already know it's 0. And then we end up having 1 plus 0 over 1 plus 0, which is 1.